Continuing on with the review problems for college algebra. Subtract. Give the answer in lowest terms. Okay, so when you're subtracting or adding fractional expressions, they need to have the same denominator. And these already do, which makes life a lot simpler. It means that the answer is just going to have this same denominator, and then the numerator is made up of this numerator minus this numerator. Now be careful, we are subtracting 7x minus 4. So remember, you're subtracting the 7x, and you are subtracting the minus 4, which would be the same as adding plus 4. So the 8x minus 7x is x. The minus 16 minus negative 4 gives you minus 12. And I factored the denominator so that I could see if there would be any common factors that we could divide out. Here it turns out there aren't. So this is already in lowest terms. But if we had gotten, for example, an x minus 10 on top, then we could have canceled that with the x minus 10 on the bottom, and the final answer would have just been 1 over x minus 2. Now on this one, we are dividing. To divide fractional expressions, the first thing we do is convert division to multiplication. Turn this into the first fraction times the reciprocal of the second fraction. So leave the first fraction the same way it is, but flip the second one upside down when you turn division to multiplication. Next thing I'm going to do is factor everything I possibly can so that I can see what all the factors are and see if I can cancel any of them. So 3x plus 3 has a common factor of 3 that I can pull out, so that it's 3 times x plus 1. X squared minus 8x minus 9 factors into x minus 9 times x plus 1. X squared minus 4x minus 45 factors into x minus 9 times x plus 5. And 2x squared plus 11x plus 5 factors into 2x plus 1 times x plus 5. Now look, we have an x plus 1 on top and on the bottom. There's an x minus 9 as part of the numerator and part of the denominator. And there's an x plus 5 over x plus 5 that we can divide out. So after all of that, what's left is a 3 over 2x plus 1. So that is the answer in lowest terms. Here the directions are to simplify as much as possible. With 12 over the square root of 6, we can rationalize the denominator by multiplying by another square root of 6 on top and on the bottom. Because that way on the bottom we get the square root of 6 squared, which is just 6. On top we get 12 times the square root of 6. And the 12 on top divided by the 6 on the bottom would just be 2. So we end up with 2 times the square root of 6. The square root of 49x to the third y to the 16th. We can break that up into the square root of 49, which is 7. The square root of x to the third power, which, well, x to the third power is not a perfect square, but we can break it up into the square root of x squared, which would just be x, times the square root of that one left over x, which has to stay under the radical sign. And then the square root of y to the 16th is y to the 8th. Now the square root of the number 16 would be the number 4, but the square root of y to the 16th power, that would be 16 y's all multiplied together, would be 8 y's all multiplied together. So the final answer is 7x y to the 8th times the square root of x. We've pulled as much as we could out from under that radical sign. For the straight line 2y equals 10x minus 10, it's asking about the slope and the y-intercept, and those would be easier questions to answer if this were in slope-intercept form, y equals mx plus b. Right now it is not in slope-intercept form because we don't have just a y over here, we have a 2y. But we can fix that by dividing both sides of the equation by 2. Just make sure that everything on both sides gets divided by 2. That turns it into y equals 5x minus 5. So now in the y equals mx plus b, the m, the slope, is 5, and the b, the y-intercept, is negative 5. So you can tell me the y-intercept is just negative 5, or you can tell me it's the point 0, negative 5. And a line that was parallel to this one would have the same slope that this one does, which would be 5. I didn't ask, but if I asked about a perpendicular line, it would have slope negative 1 over 5. Operations with complex numbers. 3 minus I minus negative 2 plus 4i. So we are subtracting here. The 3 minus the negative 2 gives you a real part of 5. And the negative I minus 4i gives you minus 5i. So the answer is the complex number 5 minus 5i. Number 8, we are multiplying 4i times 6i plus 1. 4i times 6i would be 24i squared, plus 4i times 1 would be 4i. But we don't want to leave it like that. That's not in standard form. When you see I squared, remember that's just negative 1. So 24 times I squared would be negative 24. That would be the real part of the answer. So we get negative 24 plus 4i. In number 9, we are working with the functions f of x equals x squared plus 11 and g of x equals 5x minus 1. So first of all, f of negative 3, we are doing to negative 3 what f says to do to x. Square it and add 11. So when you square negative 3, you get 9, and then you add 11, and you get 20. G of 4p. We are doing to 4p what g says to do to x. We're multiplying it by 5, and then we are subtracting 1, so we end up with 20p minus 1. In part C, we are finding the function of x that we get when we subtract f minus g. So x squared plus 11 minus 5x minus 1. Don't forget to subtract the 5x and subtract the minus 1. So we have an x squared minus 5x, and then the plus 11 minus the negative 1 gives you a plus 12. So x squared minus 5x plus 12. And g composed with f. Remember that little circle means we're composing the functions, function composition. We're taking g of f of x. So g is going to do to f of x what it does to anything. It multiplies it by 5 and subtracts 1. G of anything is 5 times that anything minus 1. So g of f of x is 5 times x squared plus 11 minus 1, which is 5x squared plus 55 minus 1, or 5x squared plus 54. Now this asks for the domain of each function. Remember, that is the set of numbers that we are allowed to plug into the function, and it will work. It will be defined. It will give us a real number answer. So for x squared minus 10x plus 25, the domain is all real numbers. For any polynomial, you can plug in anything you want for x, and you won't get any kind of error. So the domain is just all real numbers. For b, we're taking the square root of 13 minus x. And in order for that to work and to give us a real number answer, the 13 minus x has to be greater than or equal to 0. So if you set 13 minus x greater than or equal to 0 and solve for x, you'll find that that tells you that x has to be less than or equal to 13. So it's okay if x is 13. It's okay if x is anything less than 13, like say 12. But if x is any bigger than 13, then the 13 minus x comes out negative, and we're looking at the square root of a negative number. So the domain is everything less than or equal to 13. You could say it in words, you could write the inequality, x is less than or equal to 13, or you could write it in interval notation. And C, x over x plus 99. Here what we have to watch out for is we don't want the denominator to be 0. If the denominator were 0, the function would be undefined. We would have a division by 0 error. And when would that happen? When x is negative 99. So that's the only thing we cannot plug in for x. The only x for which this function is undefined is negative 99. So the domain, which is what x can be, consists of all real numbers except negative 99. Now we have some equations of various kinds to solve. They are different kinds of equations, so they require different approaches to solve them. This one is a quadratic equation. It's got an x squared in it. So one way to solve it would be by factoring. The 5x squared minus 17x plus 12 can be factored into 5x minus 12 times x minus 1. And for that to equal 0, either 5x minus 12 equals 0 or x minus 1 equals 0. So you get x equals 12 over 5, which you could also write as 2.4, or x equals 1. It would also be possible to solve this using the quadratic formula. You would plug in 5 for A, negative 17 for B, and 12 for C. And you would get 17 plus or minus the square root of 49 all over 10. And since the square root of 49 is 7, when you do the plus, you get 24 over 10, which is 12 over 5. And when you do the minus, you get 10 over 10, which is 1. So you can do it either way. X squared minus 77 equals 0 is pretty easy, but don't forget that there are two solutions. X squared equals 77, so x equals plus or minus the square root of 77. So either the positive or negative square root of 77. And here's another quadratic equation. This one cannot be solved by factoring, but there are two different ways that you could solve it. One way would be by completing the square. So if I'm doing it that way, I would leave x squared plus 2x on one side and subtract the 10. And then to complete the square, what I have to add to the x squared plus 2x is 1. Remember, the trick is look at the number in front of the x, take half of that and square it. So that's what I'm adding to both sides. That gets me x plus 1 squared equals negative 9. That means x plus 1 is plus or minus the square root of negative 9, which would be 3i. And then subtracting 1 on both sides, x equals negative 1 plus or minus 3i. You could also do this by the quadratic formula. Put in 1 for A, 2 for B, 10 for C. The part under the square root sign comes out to be negative 36, and the square root of negative 36 is 6i. So negative 2 plus or minus 6i all over 2, don't forget both parts get divided by 2, does give you negative 1 plus or minus 3i. Okay, I'm going to stop this video here and then come back in the next part with some more examples.